Hey guys.
Professor,
Hey, what's up?
do we need to have the program open, or are you just going to briefly go over it?
So I'm going to be kind of walking through the whole process. So if you want to follow along, you can have the program open. It'll save you some work later because you're going to have to do all this eventually. But if you just want to just sit and watch, then that's fine too.
So I downloaded it, correct? But I got three different ones. It says ACP 2021 and then the FinSap ICE 2021.
Okay, it should. You downloaded the just Ansys student, right? Because I know that there's like Ansys something. I forgot exactly what it is, but then we want to use the one that's kind of on the far right. And when you download it, it should come with a lot of different packages like this. Um, and then to open it, the program you want to run is called Workbench. Do you
Okay,
have
Workbench.
Workbench on your?
Hold on. I need to find the file real
Okay.
quick.
Do we want 2020, Professor, or is 2021 okay?
2021 is fine. Yeah, I just have 2020 just because I just taught this last semester. But if you have 2021, it should be fine. We're not going to do anything too advanced, so everything should be in both all versions actually.
Yeah, it does. Okay, cool.
Yeah. So if you want to start it up, it should look something like this, and then this is going to be our starting point basically.
Okay. Yeah, when I clicked on the link, there's like three different like sections.
Mm-hmm.
So I think I just downloaded whichever one made sense.
Oh, okay. Yeah. We want to. Let me see. It's changed a bit. Let me see. Download. Let's see. Yeah. So
Yeah.
these three, right?
Yeah. But
Actually, I guess they put it in the middle. I think before it used to be on the right, but this is the one that we want to use.
I think I got. Yeah, I think that's the one I got. Yeah.
Okay, great. Yeah, so it should come with a lot of stuff. Work. You can launch everything from Workbench, so that's usually the starting point. But if you want to access some of the other programs directly, you can do it here. But Workbench is kind of where we start most of the time.
Okay. Thank you.
Mm-hmm.
Yeah, they just want it to be like a really nice dinner, basically. Go ahead.
Dr. Tran,
Yep. What's up?
I have a question about Ansys on a Mac.
Okay.
Is that possible?
No.
No, okay.
Not to my knowledge. So
Not
if you,
through the virtual lab?
the virtual labs you should be able to, because the virtual
Okay.
lab runs a window machine, but you can't download and use Ansys on your Mac itself.
Right. I'm having trouble with the virtual lab.
Okay. What's
I
the?
found your video instructions. I got to the current reservations, but when I clicked get RDP file, it doesn't understand what the file is.
Okay. Can you go to where it downloaded and maybe you can run as like an administrator or something?
I've done that and it doesn't know what it is.
Okay.
I used it last semester for another class, and you have to download, I think it's like Microsoft Remote or something like that.
Okay.
And then from there, it will recognize the RPD file, and then you just copy over the password.
Microsoft Remote from the school or just from the web?
Give me 1 second. Let me look it up real quick, because I think I might still have it.
Okay.
Remote desktop.
Yeah, that one, exactly. It's orange, right?
I'm looking at it. It
That's
says
my-
it's free, so okay.
Yeah. And then the RPD file should work after that.
Okay.
Could you send that information to me too, Jonathan? So because I didn't know that you had to do that for Mac, so I need to update the information on the website with that, just so.
Yeah.
Just so
Want me to do it in chat or just email it to you?
If you can email it to me, that'd be great. Just so it's more permanent. Yeah.
Okay, cool.
Yeah. So if you're a Mac user and you're having trouble with the virtual computing labs, Jonathan's going to send me some information and then I'll update the website with that. Okay. Okay. So Chris, I guess for now, you can kind of just watch and kind of follow along and kind of maybe install in the background. But
Okay.
there's nothing you need to turn in today because all of this is going to be due next Tuesday. So we're just kind of getting a head start and I'm just going to kind of show you, kind of walk you through this process, and this will be recorded again later too. So if you want to check it out later, you can do that as well.
Okay. I'm also checking out the student software website for the Division of Information, or
Okay.
the Division of Information Technology,
Mhm.
and they don't have the RDP file there. It would be nice if it was more accessible.
Okay.
You want me to create an email? So I'm assuming that's the school email.
Yes, probably. Yeah. Okay. So let's go ahead and get started today. All right. So good afternoon, everyone. Welcome to our first Ansys activity of the year. And so this is going to be the first of at least 6. And so I have 6 made already. But depending on how things go and where the class goes, I might make more. But this is kind of like baby's first Ansys simulation. So and so if everyone who has Ansys on their computer can go ahead and start it up right now, I think that would be helpful. Or if you're using the virtual computing labs, go ahead and create a reservation and make sure that you're on there. Okay. And then we're going to be following along with this PDF. Okay. So I guess before we get started, let me ask. So how's everyone doing today? How's your first weekend of the semester? Yes. Yeah. So you're opening Workbench. So Workbench is the program that you want to open up. Mm-hmm. All right. All right. So hopefully everyone's doing well. It's funny because like before I used to work at the next to a window, so I could see what the weather is, but now I'm far away from a window, so I have no concept of what the weather looks like from the outside. So it's an interesting experience. Okay, and so if you want to follow along with the PDF, this is the one this is the one that I've posted along with the assignment. And so as you can see from this diagram here, we're basically going to be doing a simulation on a plate with a hole. Okay. And so it's basically, it's going to be a 2D simulation. And so, I picked 2D just because, this is our first, time using Ansys. So I wanted to keep it simple. But, at least throw enough complications in there where, this would normally be more difficult to solve by hand. Okay. Okay. So I guess before we really get started with Ansys, are there any questions I can answer before we get started? Okay. All right, and so you can see here, so let's start with the PDF here. So I guess, in the meantime, just so in case people missed it. So if you're running Ansys on your computer or you're on the virtual computing labs, the program that you want to run is called Ansys Workbench, okay? And so I have 2 versions of Ansys installed just because I teach this every semester. But if you go to the folder where it's installed, you can see there's a ton of programs here that that you can open up. And so the program that actually launches everything else, which is the starting point, is called Workbench. So it's usually the very last one. So go ahead and click that and kind of launch Ansys in the background, kind of while we're going. Okay. Okay. And so here's the geometry that we're going to be doing for this problem. Okay. And so we have basically just a rectangular domain, just a basic rectangular plate. We have a hole that's drilled in the middle, and so our hole diameter here is going to be 50 millimeters. Okay. The plate itself has a thickness of 5 millimeters, which is going into the page.
Professor?
Oh yeah, what's up?
For the hole, does it matter the location of it?
So the hole is going to be in the center, and so we'll just because it's a little bit simpler there, but
Okay, so just 150 millimeters. The center of the circle is 150
exactly,
and then 100.
right,
Okay.
right. I mean, you can actually put the hole kind of wherever you want, but if you want to kind of match the figures that I have later on, then the hole should go in the center. But for actually turning it in, I'm not grading these for correctness. So if you want to put the hole kind of wherever you want, or try different locations of the hole, that would be something cool to try out too. Because you can do that in Ansys because it's all virtual, right? Okay, and so the material properties of this plate are going to be listed by the following. And so we're gonna have a Young's modulus of 2 times 10 to the 5th megapascals. Okay, and our Poisson's ratio is going to be 0.3. So these are selected to match basically the default material properties in Ansys, so that we don't have to change it. But in future activities, we'll see how we can modify these guys. Okay, and I think the name that Ansys gives for these material properties is called structural steel, and so it's meant to mimic some material properties of steel. Okay. And then on the right-hand side of the plate, we're going to be applying a distributed load, and we're basically going to be pulling on the plate. Okay, and the magnitude for this distributed load is going to be 1 times 10 to the 4th megapascals. Okay, right. And so if you scroll down a little bit, you'll see that the ultimate goal of this activity, it's a very simple simulation, but I wanted to start simple just because, probably for a lot of you guys, this is your first time using Ansys. And so I wanted to kind of familiarize you guys with the interface, how to set up a simulation, how to set up a geometry, just because this is going to be the launching point for our future activities and also for your final projects. Okay. And so just kind of a list of all the different tasks that we're going to do is given here. And so we're going to start with specifying the type of analysis. Then we're going to specify our material properties. We're going to construct the geometry. We're going to mesh it, apply boundary conditions, specify which output variables that we want to see. Then we're going to run the simulation. Then we're going to view the results, and then we're going to try some different stuff. Okay. Okay. And so I'm going to switch over to Ansys now. Okay. And so if you've opened up Workbench, you should see basically this view right here. Okay. And I want to draw your attention first to the left-hand side of the screen. Okay. And so on the left-hand side, you can see here that this is a list of different analysis systems, okay? And so what this means is these are all the different kinds of physics and all the different kinds of simulations that you can run in Ansys, okay? So you can see it's a big list. And so there's a lot of different things that you can do. So you can do structural analysis, which is, we'll be spending the majority of our time doing this. But you can also do heat transfer analysis. So that's under steady state thermal, okay? You can do unsteady problems. So that's given by these transient situations here. Okay, you can do fluid flow, and so this might be something we touch on at the end of class. So you can actually run CFD in Ansys. Okay, and you can do modal stuff and vibrations, and there's a lot of stuff. Okay, but for this particular problem where we have basically a plate that's structurally loaded, we want to do a structural simulation. Okay, and in particular we want to do static structural. And what that means basically is, nothing is going to be changing with time. So we have basically just something that's going to be in static equilibrium. Okay. And so the way that we initiate this is you can hover your mouse over static structural and then click and drag that into this kind of workspace area over here. Okay. Okay. And then once you do that, you'll have this new window that shows up here, which kind of starts your static structural analysis. Okay. Okay. And so before we begin, actually, we need to do something that's really important. And no matter, how many times I explain this, people, people still ask questions about this later, is we need to transform this into a 2D analysis. Okay. So by default, Ansys is assuming that you run a 3D analysis. Just because this world is 3D, but for this particular case, we're doing just a very simple 2D one. Okay, and so this is probably the only time you'll have to do this, because for everything else we're going to do in this class is going to be 3D. But just because this one's a 2D simulation, we have to explicitly say that. And so to do that, you're going to right click on geometry and then go to properties. Okay, and then after you click properties, this new window on the right here is going to show up. Okay, and then you want to go to line 19 right here. And line 19 has you specify the type of analysis, where you can see the default is 3D. And so we want to change this to 2D. Okay. And so make sure that you change this to 2D here, and you should lose some options here because you're only in 2D. And then that should get you into 2D analysis. Okay. Okay. I see there's some questions in the chat.
Can you show that again really quick? How to convert it to 2D, please?
Sure. Yeah. And so starting from this line right here, you're going to right click geometry and then go to properties. And then after you click properties, then this right side of the screen should open up. So I think previously there was nothing here, right? And so after you click properties, then this right side of the screen comes up. And then you're going to go to line 19 of these properties and change it from 3D to 2D.
I have a quick question.
Sure. What's up?
So I don't think this matters too much, but that's line 17 on my end. Which version of the software are you using?
Yeah, I'm doing 2020. So if you have a different version of Ansys, it might be on a different line. But you want to go to the line which says analysis type. So yeah, thanks for letting me know.
It doesn't matter which one we're using, like which year.
Yeah, it doesn't matter which year. Yeah, it might. Okay. Yeah, they might put the settings in a different order, but as long as you change it from the analysis type from 3D to 2D, then you should be good to go.
Thank you.
Mm-hmm.
Quick question.
I got a question.
Yep. What's up?
Go ahead.
Thank you. For the box where you change from 3D to 2D, it's grayed out for me. I can see it 3D, but it's grayed out and I can't select anything on it.
Let's see. So you have a static structural here.
Yes.
Everything like that, and then it's just
yes.
Then it's just grayed out. Well,
right.
You're using 2021.
Yes.
Okay. Let's see. Yeah, I've never seen that before. Okay, I guess for now, we can continue on with it, and then if there's issues kind of later on, then I can go. And
sorry about that. It delayed. Now it's manipulatable.
Okay,
sorry
great.
Thank you.
Yeah.
I think the only difference between ours and yours is that for some reason you have used licenses, which I'm assuming that's the license for your software. So I don't think that's relevant. I think we should be good, right?
Okay. Yeah. It should be okay. Actually, I should probably
update. We're missing line 7 and 8 that you have. That's why.
I see. Okay. Yeah. Probably it's okay because probably your licenses are more up to date. I think because I'm using an older version, my licenses are starting to expire. So for this one, it should be okay. But for the next activity, I think I need to update them. But yeah, it should be okay. Mm-hmm. Okay. All right. And so now that we've changed it from 3D to 2D, we're going to specify the material properties. Okay. So let's go ahead and close this properties window right here. And then let's go ahead and double click engineering data right here. Okay. And so engineering data, this is where, we can specify all the different types of materials that we want to use in our simulation. Okay. And so for this activity, we're not going to actually do anything with this. But, I just want to kind of let you know where it is for now. And then because this will be something we'll be revisiting a lot later on. Okay. And so go ahead and highlight engineering data with your mouse and go ahead and double click that. And then when you double click that, it should take you to this menu right here. Okay. So the window should change pretty completely. And there's kind of a lot going on here, but I'll kind of walk you through step by step. Okay. So is everyone able to pull up this these kind of menus here for engineering data?
Yeah.
Yes. I had to close my program really quick, so I had to redo it really quick. But not that you need a pause. I just have a question. It's static structural, right?
Yes, static structural.
Are we doing Yeah. Okay. Okay. Yeah.
Mhm.
Awesome. Thank you.
Okay, and so under this menu right here, you can see all the different types of materials that you have available to you. Okay, and so we'll come back to this left hand side. So because this left hand side menu is really important if you want to do custom materials, but for now we're just kind of going to ignore it. Okay, the first place I want to draw your attention to is kind of this middle part right here, where this is our list of materials, and you can see we only have one so far. Okay. And so this structural steel is the default material that's used in Ansys. Okay, and so if you don't do anything else, you can run a simulation with structural steel, and that's kind of the default. Okay, and so with this highlighted right here, let's go down to the bottom here, and on the bottom you can see all of the different material properties for this material. Okay. And in particular, I want to draw your attention to these two lines. So in my program, it's lines 8 and 9, but I want you to look at the Young's modulus and the Poisson's ratio. So if it's a different line, it's okay. Okay. And so let's read these materials. Let's read these material properties and make sure that they're consistent with our problem here. Okay. And so if you remember from the PDF, for this problem, we want to run a simulation with the Young's modulus of 2 × 10⁵ megapascals. Okay, and so right now the display for this is in pascals, so we can change this to megapascals just to make sure. Okay, and so to do that, you can click on this down arrow and then click on megapascals right here. Okay, and then this converts the units for this guy, and so you can see here. Oh, go ahead.
It didn't show up on mine. The Young's modulus. I don't see it.
Have you clicked structural steel right here?
Yes.
And there,
Yeah.
do you have anything down here?
Under isentropic elasticity.
You have to click the little plus sign for the isentropic and it pops down.
Yes, yes. Yeah.
You
so
can
it's
right click the blank space and expand all and see everything.
Yeah.
All right.
Yeah. Thanks guys for the heads up. I guess there's a lot of kind of minor differences between the different versions where stuff doesn't show up. Was there another question?
Okay, thank you.
Okay, great. Okay. And so you can see here. Oh, your question?
Sorry, did you set the value too? I'm a little behind on this step too because I didn't have it visible at first.
So for this, we're just checking the value. So so we're not doing any changes. We're just kind of verifying that these material properties are kind of what we want them to be. Yeah.
Okay, thank you.
Yeah. In the future, we're going to change them, but for now, we're just kind of verifying these properties. Okay. And so now that we've kind of verified that the Young's modulus is 2 × 10⁵ megapascals, then we can also verify the Poisson's ratio, which is 0.3. And so, with all of that, we're good to go in this case. But for the future, we're going to have to come in here and change some stuff. But for now, we're not going to change it, so we can go ahead and close this. Right? And so if you go kind of near the top of Ansys right here, you can see that there's kind of a tab for engineering data, and we can go ahead and click the X mark here to close it. Okay. And so doing that, we're taken back to this kind of this workbench area where now we're ready to start specifying the geometry. Okay. Okay. Any questions so far on any of this? Okay. Okay. And so the next step after you specify the material properties is to specify your geometry. Okay. And so anytime you run a finite element simulation, whether it's in Ansys or any other program, your geometry is kind of the starting point. Was there a question? Okay. And so what we're going to be doing for this particular activity is we're going to be kind of drawing the geometry from scratch. And so I will say that this is a little bit unusual because most of the times when you run a finite element simulation, you've already prepared the geometry from another program. And so you probably catted up your geometry from SolidWorks. And so that's kind of the most common way. And then after you kind of, drop your part in SolidWorks, you can directly import that into Ansys. Okay. And so we're going to be doing that for all future activities. But for this one, I wanted to show you that there's at least some basic CADing capabilities within Ansys. So if you want to do something quick, you can kind of just do everything within Ansys. So you don't have to open up another program, create the geometry, and then import that into Ansys. So, if it's something quick and simple like we're doing, you can just draw it up here, and then you don't have to fuss with another program. Okay. Okay, so we're going to right-click geometry right here, and then this right-click menu is going to show up again, right? And then we want to pick, this option right here called New Design Model or Geometry, right? And so for me, it's the second option, but for you guys, it might be something different. But you do not want to use Space Claim. Okay, so Space Claim is a different CAD software. We'll see it kind of later on. Space Claim is kind of nice for us for some other stuff, but for something simple, I think Design Modeler is kind of the nicer one. Okay, and so let's go ahead and click New Design Modeler Geometry. Okay. And then another program is going to open up. I always underestimate how long it takes for this to start up. Okay, there we go. Okay, and so here's my Design Modeler interface. And so this is the version for 2020. I think it should look pretty similar to this because I think Ansys is, they're not supporting Design Modeler too much. So you guys should look pretty similar to this, okay? Oh, the license expires in 26 days, okay. I should download the new. Before the next class, I'll download the new one and see if I get kind of the same issues that you guys are having. So hopefully the in Ansys there's lots of different softwares that are involved. So hopefully it's just a license for one of the kind of the auxiliary softwares, but kind of the main software should still be okay. Hopefully, but after this lecture, I'll look into it just to make sure that we can it's all still good. Okay. Okay. All right. And so now that we're in Design Modeler, first thing that we're going to do is we're going to change the unit system just to make sure that we're all in the same units. Okay. And so on the top bar of Design Modeler right here, you can go ahead and click Units right here. Okay. And this will allow you to change the kind of the default units through which we can dimension stuff. Okay. And so for this particular activity, since everything here is in millimeters, let's go ahead and change the units to millimeters right here. Okay. 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 And so now let's go ahead and start constructing the geometry. Okay. And so the way we need to do that is we need to specify the plane in which we want to draw our geometry. And so right now we're kind of viewing, the XYZ axis kind of at an angle. Okay. And so the best way to kind of draw is to kind of constrain ourselves within just one. And so let's constrain ourselves in the XY axis. And so the easiest way to do that I found is that, you go to the bottom right of the screen where you have these kind of coordinate system here. And then you can go ahead and click the Z axis, right? And that'll force the view to kind of view right down the barrel of the Z axis. So then now we're kind of facing the XY plane just like that. Okay. Okay. And so now that we're facing the XY plane, we're ready to start sketching. Okay. And so to sketch, we can go ahead and click onto the kind of the left-hand side of the screen right here. You should see two tabs. So one for sketching and another one for modeling. Okay. So let's go ahead and click the sketching tab. Okay. And then that should change this view to sketching. Okay. And so here you kind of have some very basic kind of shapes that you can create. And so, you can see similar settings in like SolidWorks, MS Paint, stuff like that. Okay. And so in this particular case, we just want to draw a rectangle. Okay. And so go ahead and go to the left-hand side and click rectangle, right? And then go ahead and just draw a rectangle here. So go ahead and click once. That'll put one corner down and then drag the mouse over here. Okay. And so just to make sure that you have the rectangle. So the size of the rectangle doesn't really matter right now because we're going to dimension it in a second. Okay. But for now, just go ahead and draw a triangle in the space just so that we can kind of work with it from there. Okay. Right. Yes. Yeah. So if you're having trouble looking down the Z-axis on the bottom left, you should see your coordinate axis like this. Go ahead and click this Z arrow right here, and that'll look you right down the Z-axis. Mm-hmm. Okay. And so now, has everyone been able to draw the rectangle in Design Modeler?
Yeah.
Great. Okay, and so now that we have a rectangle here, we need to specify its dimensions, okay? And so on the left-hand side, so kind of the same place where you found the rectangle, go ahead and click this dimensions button right here, okay? And so now this will allow us to specify dimensions, right? And so the default mode for dimensioning is general. And so with general dimensioning, you can basically click a side of the rectangle, okay? And that'll let you dimension it, right? It's a little bit weird because it's been a while since I've used SolidWorks, but I remember before when I used it, it lets you kind of dimension it right here. But the way it works in Ansys is that you first have to kind of define that you want to dimension this side, and then you have to come down to the bottom left-hand side of the screen right here and actually put in the numbers right here, okay? And so actually this, this was pretty close to 100 millimeters, but we don't want 100. And so for this side of the rectangle, we want this to be 300 millimeters, okay? So let's go ahead and manually change that from 100 to 300.
Professor?
Yep. Mm-hmm.
I think I might have missed something, but I'm on meters. Is it under units at the top?
Right.
Yeah,
So you need to make sure you change the
I
units
missed that.
up there. Yeah. You can still walk rate in meters, but yeah, just
Okay.
300 millimeters is 0.3 meters. But then you might have to zoom in quite a bit after you do that. Yeah. Oh yeah. If you're curious about how to pan around like this, you can hold down the middle click on your mouse, and you can kind of rotate the camera just like that. Okay. Okay. And so that's the horizontal dimension of the rectangle. Oh, question?
To
Oh, your mic
be
is
clear, we're not using SpaceClaim, right? We're using Design Modeler, which is a different program, right?
Yes, yeah. So we're using Design Modeler for this. Mm-hmm. Yeah, SpaceClaim is a different CAD. It's a different CAD software. So SpaceClaim is going to be good for later on when we do other activities. But for now, let's just use Design Modeler because it's a little bit simpler. Mm-hmm.
Can you show the dimension part one more time?
Yeah. And so when you, I'll go ahead and dimension the next part. So just so you can kind of see. And so in order to dimension, a side of the rectangle, so you need to go ahead and click on this dimensions right here from the left-hand side. Okay. And then here you have all the different options for how you can dimension your shape. And so for now, we're just going to pick the general dimensioning tool, which allows us to kind of specify just the length of the side. Okay. And so to add a dimension to your rectangle, all you have to do is making sure that you have this general tab or general setting selected. Just go ahead and click a side of the rectangle, okay? And so the first thing I did was I clicked this horizontal edge and then specified it to be 300 millimeters. And so now let's dimension this vertical edge right here, okay? And so you click once and then you drag it out. And then to actually specify the numerical value of the dimension, you have to do so in the bottom left of the screen, okay? And so from our problem document, we know this has to be 200 millimeters, okay? And so now that that is done right there, okay? And so if you're kind of like me and you kind of had to enlarge the screen, you can scroll on your mouse wheel to zoom in and out, and then to kind of pan, within this this plane, I hold down Control on my keyboard and I hold down the middle mouse click, and that pans the view, okay? Okay.
I can't seem to find the option to actually click and drag the rectangle itself. Is there an option for that, or?
Yeah, so you need to draw the rectangle first. So go ahead and click draw, and then this rectangle. And
no, I did.
Uh-huh. Oh.
And then if I want to move it, just because I was in meters and I switched it to millimeters.
Okay. You can
it
zoom in.
when it squeezed it down to 300 millimeters instead of meters, it shot it all the way very far off to the side of the x-axis.
Oh, okay. Yeah, you can zoom in and out with the. Do you have a mouse wheel on your mouse?
Yeah, I was just trying to drag it closer to the origin. Is there a way to do that? Or?
Yes, we're gonna do that next.
Oh,
yeah.
okay.
Yeah. So probably everyone's rectangle kind of looks similar to this, or might look similar to Alex's, where your rectangle is kind of off center. And so the way we're going to center it is we're going to use other dimensioning tools, okay? And so instead of the general dimension, we're going to specify now a horizontal dimension, okay? And so this lets us specify kind of the horizontal distance between vertical lines, okay? And so let's go ahead and specify a distance between the vertical side of the rectangle and the y-axis, okay? And so you want to click twice here. So you're going to click once on the left-hand side of the rectangle. So that's going to highlight it in yellow. And then you're going to click on the y-axis right here, okay? And then now that's going to let you create another dimension right here, which for me is labeled H3, okay? And so we want this to be half of the horizontal length just to center it up. And so let's change this from 41 to 150, okay? And so now basically you've enforced that, you know, a horizontal distance between the left side of your rectangle and the y-axis to be 150, okay? And that kind of centers it up there. And then let's do the same for the vertical, okay? And so let's go ahead and click vertical dimensioning. And then let's click the x-axis and then the bottom edge of your rectangle. And then let's once again set this to be half of our side length, which is 100, okay? And so now we have our rectangle that's kind of centered up on our origin, which will be nice to, you know, draw our hole, okay? Okay. And so now that our rectangle is nice and centered, let's go ahead and draw the hole. And so let's go back. Oh, question?
I'm sorry, can you show that again for both the side and the bottom? I missed something, I think.
Sure. So and so to do the horizontal and vertical dimensioning, go back to the dimensioning tab, and then you're going to switch the mode from general to horizontal. Okay. And so what the horizontal dimensioning tool will allow you to do is specify kind of a horizontal distance between two different edges. Okay. And so basically the way we can use that is we can specify the distance between this edge right here and the y-axis. And then that horizontal length should be 150, which is going to be half the length of our side. Okay, and then you're going to do the same thing, but with vertical. And with vertical, you're going to do the distance between the x-axis and one of the horizontal sides of the rectangle, and then that length should be 100, which is half of 200. Does that make more sense?
Yeah, that makes sense. Thank you.
Yep. Okay. All right. So now let's go ahead and draw our hole. And so let's go back to the drawing tab right here, and let's go ahead and draw a circle. Okay, so make sure you have circle selected here on the left-hand side. And then let's go to the middle of the plate, okay, which is now conveniently our origin. So your mouse should snap there. And let's go ahead and click once to specify the center of the circle. And then go ahead and drag your mouse out and click again to define the circle itself. Okay. Okay. And so now we've drawn a circle, but it's, you know, we haven't dimensioned it yet. So let's go ahead and specify its dimension. Okay. And so let's go back to the dimensioning tool, click the general dimensioning, click one of the sides of the circle. And so this will let you specify the diameter of the circle. Okay. And if we go back to our problem statement, then we know that, you know, our diameter here has to be 50 millimeters. Okay. And so let's go ahead and on the bottom left, change this to 50 millimeters, okay? And you'll see our hole is like this, okay? Okay, so if you're following along on the PDF, you'll see that this hole was a lot smaller than some of the pictures. And that's because the pictures are from kind of an older version of this activity. So I've made the hole smaller for this one. So what you should see is your hole should be kind of small relative to the rectangle like this, okay? Okay, so was everyone able to draw the hole and dimension it properly?
Yes.
Great. Okay, and so we need to do one more thing before we move on from here. Okay, and so we need to actually create a surface from this sketch. Okay, because right now this sketch is kind of just a sketch by itself, and it's not actually a 2D surface that we can use for simulation. Okay, and so to do that, we're going to go back here on the left-hand side. Go ahead and click modeling. Okay, and then when you click modeling, it should take you away from the sketching menu and should bring you back over here. Okay, and so the sketch that we just did was in the XY plane, and so if you click this plus arrow next to XY plane, you should see this sketch right here. So let's go ahead and highlight that. Okay, and so from here, what we need to do is we need to create a surface from the sketch. And so we do that from the concept tab. So go ahead and click concept. Okay. And then from this menu, you should see a button for surfaces from sketches. Okay. So let's go ahead and click that. Okay. And then you should see something pop up right here. Okay. And so from here, we need to specify the sketch that we want to turn into a surface. And so go ahead and left click sketch right here. Okay. To highlight the sketch that we just made. Go to the bottom left of the screen and you should see a button here for apply. Okay. So let's go ahead and hit apply. And if you apply
don't need
it,
a material, or do we need like a material or anything, or?
We'll add the material later on in another part. So this is strictly just the geometry for now. Yeah.
Okay.
And so once we add the sketch right here, you should see one sketch. Okay. And then the last thing you need to do is click generate. Okay. So it might take a second. And then after you generate your surface from the sketch, you should see something like this. Okay. So you should see kind of a solid gray where we have our where we want kind of solid material, and then a hole in the middle where, you know, that's the hole that we drilled. Okay.
And it just automatically knows to does it just automatically know to fill in everything like in between the circle and the square? Or
yep. Yeah.
do we
So
have to
usually
specify that with other ones. Okay.
Yeah, I think there's settings that you can do, but I think because, you know, we have an enclosed hole right here, then I think by default, then it knows it's kind of empty space, and then everything else is solid. Yeah. Okay. Was everyone able to get this the surface from the sketch like this?
Yeah.
Okay. All right, great. And so if you've gotten to this point, then our geometry is good. And so believe it or not, what we can do now is just close this program. Okay. So don't close Workbench, just close Design Modeler. Okay. So you should have two windows open. So just go ahead and close Design Modeler. Okay.
For this one, we don't apply the thickness to it.
We're going to do that later.
Okay.
Yes. Okay. Yeah.
Just file close design. Just file close design module, or do we just click the red X top right? Does that
you can
matter?
Just click the
like
red X. Yes.
Okay. I didn't know if like I closed it, it'll just get rid of it completely. I didn't
No.
know.
So it'll automatically kind of be attached to your because Workbench is kind of working in the background, and whenever you make changes to your geometry, it's updated in Workbench. Yeah. Okay. And so now that we're back in Workbench, we need to open up a different program to actually run the simulation. Okay. And so again, remember, you know, for a lot of cases that, you know, that we'll do later on, this is actually the point where you'll start with, because you'll have imported your geometry from another software. But for this case, we created the geometry here. So go ahead and double click on model, and it should have this kind of refresh symbol right here. Okay. And so on the bottom left, you can see that you should see a message called a starting mechanical. Okay. It does take a little bit of time, because mechanical is kind of the it's a relatively big program which kind of runs our finite element simulations. Okay. And so I guess while this is starting up, you know, does anyone have any questions that I can answer?
Is there any way to like just scroll in Design Modeler, because I keep having to just zoom in and zoom out? Would be
Yeah. So if you want to scroll, you can go ahead and hold.
Easier if I could just scroll the screen left and right or something.
Right. So if you want to scroll the screen, do you have a Windows laptop or Windows computer?
I have a Windows laptop. Yes.
So hold Control on your keyboard, and then hold down the middle mouse button, and that should let you kind of scroll left and right from there.
Hold Control and the middle mouse button.
Yes, and then move the mouse to the left and right with both of those buttons held down.
Control and the middle. Okay.
You got it?
Yeah, I got it.
Okay, great. Okay, and so now that Ansys Mechanical has started up, now we need to start specifying our simulation parameters. Okay, and so the first thing that we need to do is we need to specify the thickness. And so actually, you know, we could have specified the thickness in the design modeler, but I kind of missed it. But the nice thing about this is that we can actually just apply the thickness here. Okay. Actually, first of all, let's change our units. And so go ahead and click Home. Okay. on the top of the design or the Ansys mechanical screen. And then you should see this button in the middle right here for units, okay? And so when you click that, you can see that there's different, settings for units here. And so let's go ahead and click this first one here for millimeters. Okay, so there's different options for millimeters, and depends on what other units you want for like forces and for force and for mass and things like that. But I think we're okay with just having this one right here. Okay. Okay. And so when you change the units to millimeters right here, and you go ahead and click surface body here under geometry, you can see that we have this option in the bottom left to specify the thickness. Okay. And I think from this problem, our thickness is 5 millimeters. Let me go ahead and double check that. Yes, our thickness is 5 millimeters. And so let's go ahead and change this thickness setting to 5 right here. Okay. Okay. And so, because that's going to be important, because that's going to affect our results. Okay. Okay. And so now that we've specified the thickness and we've loaded in our geometry, our next step is to mesh it. Okay. And so if you remember from last week, when we put a mesh on a finite element geometry, what we mean is we're going to break up our geometry into lots of simple shapes. Okay. And so, if you go to the left-hand side of the screen where, this outline right here kind of shows you kind of the step-by-step process for, all the different settings you can do on your simulation, and you come to mesh, you should see that there's kind of a yellow lightning bolt here. Okay. And so in Ansys, if you see kind of a yellow lightning bolt next to a setting like this, that means there's something that you need to do before you move on. Okay. And because right now it's showing a yellow lightning bolt because we haven't produced our mesh yet. Okay. And so if you want to just do kind of a very simple mesh, and you just want to use just the automatic settings, what you can do is you can right click onto mesh right here and then click generate mesh. Okay. And so it might take a little bit of time. You can check the progress here on the bottom left. Okay. And then when it completes, you can see that we have a mesh that's generated right here. Okay. And so you can see it's taken our geometry and broken it up into a bunch of, in this case, 4-sided rectangles. Okay. And so it took our big rectangle and broke it up into a bunch of smaller rectangles. Okay. Okay. And you can check the statistics of this mesh too. So you can check, how many shapes that you have and how many kind of vertices that you have. Okay? So those are called elements and nodes. And so if you click this this plus arrow next to statistics, you can see that this mesh has 351 nodes, okay, and 101 elements. Okay? And so you can count them if you want to verify it, but it's there's better uses for your time. So you can trust that the element count is correct. Okay. And so this is kind of the default mesh. So if you want to just run a very quick simulation. Oh, go ahead. Is that your question?
I don't know. Mine was being done, so I'm kind of behind. Me too. I'm just going to have to rewatch it. Okay.
Yeah, if you guys, I know everyone's programs are going at a different speed. I do want to make sure I run through the whole thing today. So, I am going to, kind of keep going. But if you kind of fall behind a step or two, we can definitely talk after the lecture, or you can watch the recordings afterwards. Yeah.
What was the thickness?
The thickness was 5 millimeters.
Oh, okay, cool.
Yeah. And if you so if you check your mesh statistics, you probably won't have exactly the same numbers that I have, because there's some randomness associated with creating a mesh. And so if you don't have exactly these numbers, it's okay. It's as long as you're kind of in the same ballpark, it's fine. Okay. Okay. But for this, we're actually going to modify these mesh settings a little bit, because this right here, where you only have like 100 elements, this is a pretty coarse mesh. And so, typically what you want is you want your mesh to be fine enough such that you have an accurate simulation, right? If you compare this to kind of like an image, this is kind of like a low quality, a very pixelated kind of image, okay? And so the first thing we're going to do is we're going to modify the size of the elements, okay? And so to change your mesh settings, the best way to do it that I find is to right click on mesh, okay? And then you're going to highlight your mouse over insert. And then you can see here all the different types of settings that we can do, okay? And so the first setting that we're going to put in is sizing. And so sizing will allow you to modify the size of the elements, okay? So let's go ahead and click sizing. Okay. And then after you click sizing, you'll see the bottom left-hand side, bottom left of the screen change into this menu right here. Okay. And so the first thing that you need to do is you need to specify the geometry on which you want to specify this setting towards. Okay. And so first thing we're going to do, we're going to go down here where it says geometry. Right now it says no selection. So go ahead and click the box which says no selection, and that'll let you basically select certain things. Okay. And then from here, you're going to left click on the surface of the plate. Okay. And it should turn green. Don't know why it's not turning green. Okay. So usually it turns green to let you know that it's selected, but if it's not, then it's okay. And then after you've clicked this, go ahead and hit apply. And then what you should see is that this geometry should turn from yellow to white, and it should say one face. Okay. And so that one face specifies this surface that we're modifying right here. Okay. Okay. And so the next thing that we're going to modify is the actual size of the elements. And so if you go back to the bottom left of the screen, you should see a row here for element size. Okay. And so right now it's using the default value of 30 millimeters, or approximately 30. And so let's take this down a little bit. And so instead of 30, let's use an element size of let's take it down quite a bit. So let's do 10. Okay. And so what that's going to do is it's going to modify the mesh such that the maximum size of these edges is only going to be 10 millimeters. Okay. And so let's go ahead and remesh and see how that updates. And so to remesh, you can go ahead and go back to the left-hand side of the outline, right-click mesh, and then click update. Okay. Right.
When I clicked sizing, my mesh lines disappeared. How can I bring them back?
Try right-clicking mesh and click update.
Okay, I think that worked.
Okay.
Well, what was the step after that, Star? You just resized one of the squares?
Right. So so under the sizing option here, you want to click you want to click the face here to select it. So normally this guy is yellow right here, this geometry. So click geometry, click the face right here, and then click apply. Right. And so that'll select this face. So that tells us, we want to change the mesh settings on this particular face. And then we want to change the size of the elements right here. So I think by default, it should be around 30. And so you want to change this to 10. And so after you change it to 10, go ahead and right click mesh and then click update. And then you should see the size of the elements here go down. Okay, so now you should have a bunch of smaller squares instead of a few bigger ones. Yeah. Okay.
Okay, thank you.
Yep.
Professor, does it matter if my nodes number is like half of yours?
Yeah. So don't worry about the exact number too much. And so
Okay.
Everyone's is going to be a bit different. And so half is a little bit high. So maybe I'll check it out afterwards. But it's not, if it kind of visually looks kind of the same as this, then that's okay. Yeah.
Okay, sounds good.
Yeah. Okay. And so you can see, after we've updated the size of the elements, the number of elements are updated. Okay. And so before we only had about 100 elements, and so now we have 573. So it's gone up quite a bit. Okay. And so that's generally what you can expect. So if you reduce the size of the element, then you need more elements to kind of fill that space. Okay. And so more elements means generally more accuracy. And so, you want to find kind of a good balance of, accuracy versus number of elements, because the more elements that you have, the higher the cost of your simulation is going to be as well. Okay. Okay. And so one other thing that we're going to change here is we're going to specify what's called the functional form of the solution. Okay. And so we're going to add another mesh setting. So go ahead and right click mesh, go to insert, and then you're going to come back to this menu right here. And instead of sizing, you're going to add a setting for method. Okay. So let's go ahead and click method, right? And then the same thing is going to apply here. So if we kind of click away here, you can see that there's no geometry selected for this method setting, right? And so in order to specify the method, we're going to left click this if you haven't already, and you should see it change to this form right here, which is apply and cancel. Okay. And so same thing that we did for the sizing, we're going to just click anywhere on our surface here to select it. Okay. I guess it's a little bit hard to see, but you can kind of see that the surface is kind of outlined in green. And so that might be one way that you can tell. Okay. And then go ahead and click apply. Okay. And you should see the geometry line change to one body, which means that, you know, we're doing the setting on this whole body right here. Okay. Okay. And so now here we have two different things that we can change. And so we can change the shape of the element. Okay. And so right now we're doing what's called quadrilateral dominant. And so what that means is that the shape that the mesh will choose are these kind of squares right here. So that's what it means by quadrilateral. And so we can change this. So we can change it to triangles if we want. Okay. And so if we want to change it to triangles, we can do that. And then we can right click mesh and then click update, just same as before. Okay. And you can see now our mesh is comprised of triangles instead of squares. Okay. And so for right now, you know, we're going to use squares or quadrilaterals, but then I want you to try a triangular mesh later on. Okay. And the pros and cons of quadrilaterals versus triangles is something that we're going to, you know, talk about throughout the class. Okay. But generally, you know, generally speaking, if you can mesh your geometry with quadrilaterals, that's usually more preferred. Because if you go back to our mesh statistics here, you can see the number of elements went up pretty dramatically when we went with triangles. So triangles basically, you know, require more elements, but we didn't change anything else. Like we didn't change the size of the elements and we didn't change their geometry. So if you can get away with using quadrilateral dominant, then that's usually the preferred method because that's a little bit, that gives you a little bit more of an efficient mesh. Okay. Okay, so that's how you change the shape of the element. And so the next thing that we're going to change is the order of the element. Okay. And so we'll talk about this, you know, a lot kind of later on, probably in the latter half of the class. But basically you can change, you know, what type of function that's going to be used on your element. Okay. And so if you kind of remember briefly, we mentioned last week that part of finite elements is that we have to assume that we have to assume a form of the solution on our elements. Okay. And so right now you can see we have two options here. So we can either assume a linear function or we can assume a quadratic function. Okay. And so for this particular case where we're running a structural simulation, it's usually best to do a quadratic element order. Okay. Because that kind of when you try to run a structural simulation with linear elements, you kind of run into a lot of issues down the road. So for structural simulations, it's better to go with quadratic. Okay. And so after you change it to quadratic and making sure that you're quadrilateral dominant, go ahead and right click mesh and click update. Okay. Okay. And you should have a mesh that kind of looks like this. Okay. Okay. Any questions on this so far?
Wait, we're doing triangles? I thought you said you wanted us to keep it as quadrilaterals.
Yeah, we're doing quadrilaterals. Yeah. We're doing triangles.
Oh, okay. Oh, you just updated. Okay.
Mm-hmm. Yep.
I'm not sure if it's just me, but when I right click mesh and then hover over insert, I'm not seeing automatic method on my end.
It should it should just be method.
Yeah, I only have sizing. There's nothing above it, and then I have everything below.
Okay. Let's talk about it after the lecture because I want to make sure I get through kind of everything else. But,
yeah, no problem. Thank you.
Mm-hmm. Okay. All right. So
you might have it already added underneath mesh.
No, I only have face sizing, but that's okay. I'll figure it out later. Thank you.
Yeah, let's talk after the lecture and let's debug it there. Okay. Okay. And so one more thing that we can do with the mesh is we can add some refinement. Okay. And so what refinement means is that it allows us to use smaller elements in just kind of a certain area of the mesh. Okay. And so this can be useful because, you know, a lot of times there's some areas in the mesh or some areas in our geometry where we expect to have, you know, very high stresses or some very interesting behavior phenomenon. Okay. And so in this particular case, you know, if you kind of remember from your statics class, we should expect to see some stress concentration around the hole. Okay. So in these cases, it might be beneficial for us to refine the mesh around the hole just like that. Okay. And so there's one more setting that we can do. So go ahead and right click mesh, go ahead and click insert. Okay. And then we're going to use this third option here for refinement. Okay. Okay. And so we want to refine the mesh around this hole. So we want to select just this kind of ring right here. Okay. And so to do that, we want to make sure that we can select an edge right here. Okay. Because right now the default is that, you know, when you mouse over something, you're selecting kind of an entire surface. So you're kind of in surface select mode. And so in order to make sure that you can select the edge, you want to come up to kind of the middle of the window right here and click edge. Okay. And so this will allow us to basically select an edge. And so if you kind of mouse around the model, you can see that, you know, the edges now are lighting up instead of the entire surface. Okay. And so let's go ahead and click the edge around this hole. Okay. And so now the only thing that should be highlighted in your geometry should be the inner hole right here. Okay. So go ahead and click apply. Okay. And so now we have a refinement here. And then let's change this refinement ratio to 3. Okay. And so using kind of the buttons here, go ahead and click to the right and click 3. Okay. And then after you do that, go ahead and update your mesh. Okay. And then from there, you can see that, you know, we've refined our mesh here. So you can see that the elements around the hole are a lot smaller than the elements kind of around here. Okay. And so this really helps because, you know, once after we run the simulation and we see the stress concentrate in that area, then we're going to be more confident that our stresses are going to be accurately computed. Okay. Okay. And so that's the basics of meshing. So basically, you know, any Ansys job that you run, you want to make sure that you modify the size to make sure that it's appropriate. You know, if it's showing up for your version, you can go ahead and modify the methods that you can change the shape and the element order. And then anywhere in the mesh where you want to add some refinement, you can do so with that. Okay. And so there's a lot of other options for meshing, but these are kind of the basics of what you kind of need for every Ansys simulation. Okay. Okay. And so now we're done with the mesh. And so the next step that we're going to do is the boundary conditions. Okay. And so by boundary conditions, remember what I mean by that is we want to specify how the solution behaves kind of at the extremities of our model. Okay. And so in this particular case, we have 2 boundary conditions that we want to apply. And so if you kind of go back to our PDF here, you can see that we have one boundary condition on the left edge of the rectangle. And so this boundary condition here will be a fixed constraint. Okay. And so what that means is that the plate is going to be kind of, you know, literally bolted to the wall. And so, you know, that left side there won't be able to move. And then we have another boundary condition on the right side of the plate. And then this is our loading. And so this is going to be a force basically that we're going to be pulling our plate with. Okay. Okay. So let's go ahead and apply those. And so to apply boundary conditions, you need to start from the left outline menu. Okay. Go ahead and right click static structural A5. Okay. And then you're going to highlight insert. And then from here, you can see all the different types of boundary conditions that you can apply. Okay. And so there's a lot because there's a lot of different types of conditions that you can apply onto a structural simulation. Okay. And so let's start by fixing the left-hand side. Okay. And so the way that you basically force something to kind of be still or to be not move in the simulation is to apply what's called a fixed support. Okay. And so let's go ahead and click fixed support right here. Okay. And then for fixed support, you know, we need to specify the location in the model where we want to apply it. Okay. And so just so that we're consistent with our problem document, let's go ahead and click the left-hand side of the plate right here. Okay. And let's go ahead and click apply. Right. And so now we've applied a fixed support here. Okay. And so now when we run our simulation, this side of the plate here is not going to move at all. Okay. Okay. And so next thing that we need to apply is our loading. Okay. And so if you go back to our PDF, you can see our loading is given in terms of a pressure value. Okay. So it has units of megapascals. And so if you kind of remember from your previous classes, pascals is a unit of pressure. So it's a force divided by area. Okay. And so let's go ahead and apply that as a pressure boundary condition on our plate. So let's go ahead and right click static structural, go ahead and click insert. And then we're going to apply a pressure boundary condition. Okay. And so what this will allow us to do is it'll allow us to specify a pressure, you know, on our system. Right. So let's go ahead and click pressure. Right. First step again is going to be to choose the edge on our rectangle where we want to apply pressure. Okay? And so since our pressure is going to be applied on the right side of the plate, let's go ahead and click on this right edge right here. Okay? And then let's go ahead and click apply. And so that basically states that, you know, we want to apply our boundary condition on this surface right here. And then now let's go ahead and input our magnitude. Okay. And so if we go back to our PDF, you can see the magnitude of our loading here is going to be 1 × 10⁴ megapascals. Okay. And so let's go ahead and put that in here. Okay. And 1 × 10⁴ is going to be 10,000 megapascals. Okay. And so when you put that in, make sure that that your units here are megapascals. Okay. But if it's a different unit, you know, you make sure that you either perform the conversion, or you can change your units here to this. Okay. And so if you have your units as millimeters and newtons, then you should be able to input your pressure as megapascals. Okay. Okay. And so any questions on the boundary conditions? Oh, sorry, I didn't see. Oh, the chat wasn't updating for me, so I didn't see that. Yeah, it's my cat. My cat is hungry, but she's getting fed right now. Yeah. Okay. Yeah, sorry about the chat. It's sometimes the Zoom's been being weird this semester, or sometimes it doesn't give me a notification when there's something in the chat. So I kind of just go through and don't see the chat. So yeah, so I'll catch up with that a bit later. But was everyone able to do the boundary condition? So you should have 2. So you should have 1 fixed support on the left, and you should have a pressure boundary condition on the right. Okay. And so once you do that, if you kind of noticed before that there is a question mark next to static structural, okay? And so what that question mark basically says is that, you know, your simulation can't run yet. And so to run any kind of finite element simulation, you need at least 1 support and you need 1 load, okay? And so in this case, our support is our fixed support over here. And then our load is the pressure boundary condition that we applied on the right, okay? And so now that we've applied our support and we've applied our load, now we're ready to run the simulation. Okay. And so technically you can solve it right now, but right now you wouldn't be able to view any of the results. Okay. And so let's quickly look at and see, you know, how do we specify which results that we want to see. Okay. And so to specify results, you're going to go to the outline menu on the left. You're going to right click solution A6. Okay, and then you're going to click insert, and then you're going to go to deformation. So the first thing that we want to look at is we want to see how much is our plate deforming as a result of the stress. Okay, so let's go ahead and click total. Okay, and so this will measure basically how much the plate is deforming. Okay, and the next thing that we want to do is we want to view the stresses. Okay, and so there's a lot of stresses that you can view here. Okay. But the one that's typically viewed most often in finite elements is what's known as the equivalent stress. Okay, and so you can think of the equivalent stress because, you know, we know that stress is kind of a matrix quantity. So you have kind of your normal stresses and your shear stresses. Equivalent stress is kind of like a scalar representation of all the stresses. You can almost think of it as like stress and magnitude. Okay, it's not exactly that, but that's kind of how I think about it in my head. Okay. And so let's go ahead and click that. And so now we have 2 outputs that we're ready to view, okay? And after you've done those, now we can go ahead and solve our model, okay? And so, you know, before you click solve, let's go ahead and just double check everything. So let's make sure that we have all our meshing, okay? We have our boundary conditions. So we have our fixed support and our pressure. And we also have our output fields, which is deformation and stress, okay? And so once that's done, you can go ahead and click solve. Right. And then now Ansys is going to run your simulation. So it's could take a little bit of time. And if you want to check the progress, you can check the bottom left of the screen. Okay. Right. You might have a window pop up and Windows Firewall might ask if you want to allow Ansys access to all your personal data. So it's okay. I've been using Ansys for a few years now, and I can say that no Ansys agents have shown up at my door. So that's okay. Okay. hopefully no one charges anything to your credit cards. Yeah. And then after you you do that, what you're viewing here is your simulation results. So here is your simulation results. Okay. And so what you're viewing right now is the total deformation. Okay. And so the way to kind of read this is to kind of read it as a color map. Okay. And so your color bar on the left right here shows you kind of the relative magnitudes, and things typically higher values in Ansys are typically given a color of red, and then lower values are given a color of blue. Okay. And so from here, let's start on the left-hand side, and you can see on the left-hand side here, we have 0 deformation, right? And that makes sense because remember, we applied a fixed support on the left-hand side of our plate. Okay. And so it makes sense that we have 0 deformation there. And on the right-hand side, we have maximum deformation, which is where we're pulling. Okay. And you have kind of a gradient of deformation as you go throughout the plate. Okay. So this intuitively kind of makes sense. So if you kind of take a rod of metal or a sheet of metal, and somehow you're the hole, and you can kind of pull it like this, you should see the entire thing kind of stretch. Okay. Okay. And so that's the deformation field. So was everyone able to get this this deformation field right here?
Professor, I wasn't able to ask earlier. With pressure, we just applied it on the edge and we didn't really do anything about it? Can we just do like a compression, or
yeah,
you know what I mean? Because we just did it automatically just assume it was tension, or?
Yeah. So actually right now it actually is in compression. So actually, if you go back to the original geometry, you can see things are being compressed.
Oh, it's compression. Oh.
Yeah. Yeah, so actually the default for pressure.
Oh, okay. Oh, yeah.
And I'm glad you brought this up, because the default for pressure is to actually apply it in compression, which is kind of normal to that surface. And so if you want to have it be in tension, you can make it a negative pressure right here. Okay.
Okay, all you do is just make it a negative. Okay.
Right. And so that's one way that you can do it. So if you click solve, and then it's going to solve your problem again. And you click the total deformation field, you can see now it's being stretched right here. Okay. Another way that you can do it that I actually have in the PDF is that you can actually specify the X, Y, Z components of the pressure force. Okay. And so to do that, you can click define by. And so right now we're defining it to be normal to. And so what that means is that the force is being applied normal to that surface. Right? Instead, you can change it to components. Okay. And so now you can specify the X, and in this case, X and Y components of the force. And so since we want to pull this plate in tension, one way that you can do this is you can apply an X component of the force of 10,000 megapascals. Okay. And then you can keep the Y component 0, because we're not going to do anything with that. And then you can click solve again.
How did you do that real quick? You clicked on pressure, right?
Yep.
And
yeah.
then...
And then you should see a line here called define by. And so I think the default is normal to. And so you want to change that to components right here.
Oh, okay, got it.
Yeah. And then you can change the X and Y coordinates right here. And then that'll basically make it so that you're applying a force in the positive X direction, which in this case is tension, okay, which is stretching it like that. Okay. Let me see some questions in the chat. Okay. And so that's the deformation field. And so that's the, if you want to see how much your simulation is deforming, that's how you can do it. Okay. The other thing that we want to view, which is probably the more interesting result field, is the stress. Okay. So let's go ahead and click equivalent stress. Okay. And now you can see areas in your model where the stresses are concentrated. Okay. And so once again, we're using this this color bar right here. Okay. And so we're using red here to indicate areas of high stress. And then blue indicates areas of low stress. Okay. And you can see right here, it's a little bit harder to see, but around the hole, we have stress that concentrates around this kind of area right here. Okay. And so that kind of tells you where, this plate is most likely to fail. And so if you kind of increase the loading, where you would see kind of the plate kind of rupture is on this areas right here, because that's where the stress is kind of concentrated. Okay. And so this kind of shows the benefits of finite elements, because normally this would be you know, a little bit hard to do with hand calculations, but with Ansys and finite elements, you can easily simulate something like this and see kind of right away where the stresses are concentrated. Yeah.
How would Ansys deal with something if the pressure applied would actually break the bar? Would it like, because it's not real time, so would it just show a separation or?
Right. So right
You know
now
what I mean? Like, would
it won't actually separate. And so because right now you're assuming kind of a linear material model, so it'll show a stress that might be something that's gigantic, that might be above the yield stress of this material. But you know, that's kind of the limitations of this. So there's another type of analysis that you can run in Ansys called buckling that can show that. Yeah. Okay. So I see that some people are having some issues in the chat where you can't see the results. Okay. And so that might be because your geometry is not specified correctly. So when you specify your output field right here, you want to make sure that you specify this to be all bodies. And so I think what can happen sometimes is that, you know, some people can just I don't know why Ansys does this sometimes, but by default it might just specify the results on this line right here. And so if your geometry here is just a line and not all bodies, you need to change it so that, you know, you click this and then you select kind of all the bodies in this solution here. Yeah. It says it says all bodies, but it's just lines. Okay. Okay, let me see. You might have to go display. Let's see. It shouldn't be a hardware thing, because this is a pretty light simulation. Let's see. Try going to display and then click display style and make sure that you're on body color right here. There are colors, but no line. Oh, if there's no lines, then that's okay. So the lines are just there to kind of remind you what the mesh looks like, but the color is just there for. I mean, the color kind of actually shows you what the results are. Yeah. Okay, so you got an error. Internal solution magnitude limit has been exceeded, and so usually that error is you know, if you have kind of too many elements in your mesh. Yeah, so probably there's something in the mesh. So so let me take a look at that. Okay, and so we have some time left in the class, so I do want to spend some time debugging, you know, people's issues. But if you were able to get to this point in the activity and get your color contours here, whether you have mesh lines or not is not that important. For some reason, Ansys kind of turns that on and off for me too. But as long as you can have these displayed, then you're good to go to start with the activities. Okay. And so I'll stick around for another, you know, another 10 minutes. I can't stick around too long because I have another lecture after this. But I do want to, you know, try to help people debug their stuff. But, you know, if you got to this point, then, you know, that's all I had planned for today. And so if you want to sign off, you know, definitely feel free. So I don't want to hold you. And so thank you everyone for tuning in today. I know that there was kind of a lot of, you know, mix-ups with the different softwares versions, but you know, hopefully, you know, throughout the semester, we'll be able to kind of iron those out. I'll download the newest version of Ansys just so, you know, I can see all those issues kind of with you guys. Because yeah, I think there might be some issues just because we're working with different versions. So thank you guys for tuning in today. Thank you guys for your patience. You know, hopefully this kind of gives you a first look at Ansys. And then on Thursday, we'll come back and we'll resume kind of where we left off last Thursday. Okay. And so thank you, everyone. Have a good evening. Okay, so Sarah, let me look at your issue first with the automatic method. And so when you so what version of Ansys that are you working with?
2021 R1, I think. Yeah.
Okay.
Actually, I figured that one out. I got automatic method working, but I just had to stop there, so I didn't get to follow the rest. So I was just gonna ask you, do you upload the recorded lectures?
Yes, yeah. So I upload them. They should be up, before tonight. And so I usually, after the Zoom call ends, Zoom takes about 30 minutes to convert the file. And during that time, I have another lecture. So I usually start uploading to YouTube around like 7 p.m. And though it should be available like 7:30, 7:45 about then, and then it'll be up on Canvas from there. Yeah.
Okay, where on Canvas could I find the link?
Yeah. So on Canvas, if you go to our course page, and you go to this is our homepage here, and on the bottom here you have the course outline, and so you can click on each of the weeks. And so if you click week 1, you can see these are the recordings from last week. But for this one, since we're in week 2, you're going to click week 2, and then this link right here will become active, after I'm done uploading the lecture. Yeah.
Okay, sounds good. And we finished the activity, right? So if we're done with it, we can just turn it in.
Yes. Well, I mean, there's a bunch of questions at the bottom of the PDF, so make sure you answer all those questions. Because I want you to kind of play around with the settings a little bit in Ansys, and there's also some stuff, pertaining to the stuff that I lectured on last Thursday. So make sure you answer all those questions, and then once you're done with that, you can turn it in. Yeah.
Okay, sounds good. And I think a lot of students are asking about saving, and that was kind of my next question too.
Yeah. Okay. Oh yeah, saving. I always forget to do this. So to save your Ansys projects, I guess a lot of people left now, but this will show up in the recording. You need to save it from Workbench. And so from Workbench, you can go ahead and click Save. And then this will allow you to choose, where you want to save it. And so for now, let me just save to my desktop. And so let's do, I've already done tests. So let me do test Ansys 2021. Okay. Okay. And then that'll save your Ansys project to your desktop. Okay. And so if you go to your desktop, you should see an Ansys file called test Ansys 2021, and that's what you need to open up. Okay. But it doesn't actually store all the files here. So this is actually the file that you open, but all the actual like CAD files and all the mesh and everything, that's actually stored in this folder right here. So Ansys will actually create two things. So it'll create this project file, and it'll also create a folder right here. And this folder contains all of the CAD files and all that stuff. So if you want to, if you're working on the virtual computer and you want to move this back to your desktop to work with, you need to transfer both of these things. So both the folder and the project file right here. Yeah. Okay.
Okay, and when we turn in the activity, if we have to answer some questions, like, do you want us to type them and turn in two files, like a document and the activity file?
So it's I just want the document. So you'll see in the PDF. So like when you run your simulations, all I'm asking for is just for you guys just to take kind of screenshots of the results. And so if you can combine all of those into a single document, that would be the best for me, because usually I don't open up all the individual Ansys files, because that kind of takes a little bit too much time. So if you could kind of just put it all into a document, that works the best for me.
Okay, sounds good. Thank you. Have a nice rest of your day.
Thanks. You too.
Quick question.
Yeah, what's up?
So like, I know how you said that it puts it into a separate folder.
Yeah.
So when we go to open it, how do we open it?
Yeah, so to open it, you can either open up Workbench first and click open. And then when you click open, you just go to the project file. And so the project file will automatically look into the folder for all of that stuff. Or you can just go to your desktop and just double click the project file itself. Yeah.
Okay.
Yeah.
Okay, cool. And it'll open up the CAD model and the analysis, right?
Exactly. Yeah. Mm-hmm.
Okay, cool. Thank you.
Yep. All right. Did anyone is anyone else having issues? I know Van, I think you had issues with the limitation, right? Are you still here?
Oh yeah, I think I missed a couple of small steps, so I'm gonna rewatch your lecture.
Okay. Yeah, it might be because did you change the analysis type to 2D at the beginning?
I did, yeah.
Okay. Usually that's kind of the issue that people have, but if you're still having issues with that, just send me an email, send me some screenshots, and then I can help you debug. What version are you working with?
2021.
2021. Okay. I should
Yeah, I'll
really
let
download
you
21. Know. Okay. Yeah, keep me updated, and it's if you still can't run it, just then we can debug it there.
All right. Thank you.
Yep. Mm-hmm.
All right.
right. Did anyone else have any other questions? Scroll down the chat. Oh. Yeah. So if you look into the place where you installed it, let me see where I've installed it. Let's see, program files. Ansys student. Let's see. I remember I had to look for this once because it was Ansys was kind of being weird to me. There should be an executable there called Workbench. So if you kind of search in that folder and search for Workbench, then that's the executable that you should use. But I can't seem to find it right now. Yeah, go ahead, search through that folder and see if you can find the Workbench executable, and then try running that. Yeah. Okay, so I need to sign off because I have to run to another lecture. Okay. Oh. Yeah, so the application that you want to look for is Workbench. And so if you can find that one, then that's the one. I'll look into my program files after the lecture, and then if I can find it, then I'll let you know where I find it. Yeah. Okay. So I got to run. So I'll see you on Thursday.